students, welcome to the class. So before we start solving numericals related to spherical mirrors, let us quickly revise sign convention that we need to use to apply during solving such problem. So the sign convention, also called the new Cartesian sign convention, as you know, if we just suppose this is a spherical mirror, that's as you do in mathematics, you just make 4 parts of it, and then let us say if this is the principal axis, this is the pole, so we measure everything with respect to the principal axis and the pole. That means any light ray which is passing in the direction of the incident ray or the principal axis, any incident ray which is moving towards the pole is taken as positive. Means anything which is directed this side is positive and anything which is away from the pole is taken as negative. Second point, anything which is above the principal axis is taken as positive and any direction, any height which is below the principal axis is taken as negative. So these are the 4 points related to sign convention that we have to remember while we apply this in solving numericals related to spherical mirrors. In this question and in every question, before you start solving the question, the first point that I suggest is you should write what all is given, and whenever you write what all is given, write with proper sign convention. And second point, remember what is being asked, means what you have to find. So if you write these clearly, then things will be very clear and you will know how to proceed. So here you have been given the magnification 3 times and real image. So remember, whenever the image is real, it is always inverted. So this point you have to remember, real is always inverted and virtual is always erect. So if it is a real image, means it is inverted image. So magnification will be negative. Here it is 3 times magnified, means magnification is -3 and the object distance is 10 centimeter. Now we know that object distance, we write it as u, and we know that by default object we always place at the left side of the mirror. So means object distance is at left side from the pole, so negative. So it is -10 centimeter. And we have been asked to find the image distance, that is V. So now you will get a clear picture what is given and what you have to find out, so you know which formula you have to apply. We can apply the formula of magnification, that is for mirror, magnification is equal to -V by U. So let us put the values here and we have to find V. So let V be there and we shift this, it is this. So -V will be equal to -3 multiplied by -10, that is we get 30. This implies V is equal to -30 centimeter. That means the image distance is -30 centimeter. Means it is in front of the mirror. So if this is the mirror, the image is -30, means from here it will be 30 centimeter. This side, minus will tell us that image is formed this side on the left side. Okay, now in this question, let us see what all is given. We just remember this is a concave mirror. So we have been given the focal length and the focal length is given as 20 centimeter. Since it is a concave mirror, keep in mind for concave mirror focal length is always negative. So it is -20 centimeter. At the same time, you have been given the magnification twice, means 2 times, that is 2, and it is a virtual image. So since it is a virtual image, means erect image. So magnification will be positive. So M is equal to +2. Okay, and we have to calculate the object distance. Okay, now let us proceed. Now here you see nothing is clear here because we know the formula of magnification, that is equal to -V by U, but we neither have V nor we have U, and also for magnification we have H2 by H1. This also cannot be applied. Now what to do? So let us find out what we can do here. So I think this formula will not help us. So let us erase this because we know that we have the mirror formula. The mirror formula is 1 by F is equal to 1 by v plus 1 by u. So we get some clue from here. We have to find u and we have been given f. So let us see if we can use this formula. So let us put the value of magnification here, that is 2 is equal to minus v by u. Now since we have to calculate this u, let us leave it and let us find what we can do. So can we write minus v is equal to twice u, or we can write v is equal to minus twice u. Let us leave it here. We will use it in this formula. Okay. Now let's move to this formula and apply this value here. And we know the value of f also. So can we write 1 by minus 20 is equal to 1 by minus twice u plus 1 by u. So let us take all the negatives to the numerator. This is simple mathematics. So nothing to worry. As you do in mathematical equations, you have to proceed. So let us solve the right side first. It has this. So we get, this is 1 by twice u, and this side we have this value. So now let us move to find the value of u. So this will be minus twice u is equal to, it will be 1 into 20, or this minus u will be equal to 20 by 2, that is 10, and if we shift the minus from here, it will come here. So it comes to be the value of object distance. Object distance is minus 10 centimeter. So the distance is 10 centimeter. This minus symbolizes that object is on the left side of the mirror, that is on the left side of the principal axis. Okay, let's move to another question. Now here you see, here again remember, concave mirror. Okay, focal length should be, yes, negative. So focal length is negative and it is given 18 centimeter. And object distance, that is u, and you know by default object distance is always negative because we always place the object on the left hand side of the mirror. So since it is very clear, you have been given the focal length, you have the object distance, so to find the image distance simply we can put it in the mirror formula. So let us proceed. You all know the mirror formula. 1 by v is equal to 1 by f is equal to 1 by v plus 1 by u. So what I prefer is, it's your choice, you can move forward as per your wish. What I prefer is, whatever is the unknown quantity, you leave it on one side and the known, let us take it to the other side. So let us leave 1 by v here and it should be 1 by f minus 1 by u. Now just put the values in this formula. So this implies we can write it like this: 1 by v is equal to 1 by f is minus 18. So let us directly take it to the numerator. It's your wish. You can add one step also. I am just taking it directly. And minus, it should be minus 1 by 9. So just solve it. I know you all can very easily do it. So it will be 1 by 18. 1 by v is 1 by 18. So v will be equal to simple 18 centimeter. Now what do we know about the position and nature of image from here? Position is equal to, position will be 18 centimeter on the other side of mirror. On the other side of the mirror that you can write. Okay. And what about the nature? See, since you see a positive sign here, nothing means positive. So positive sign always indicates that this image is a virtual image. Okay. So it is a virtual image. So we can say the image formed is virtual. Now what we need to know more? We need to know the size of the image. So now we can simply erase this, and in place of this, since we have the value, we can write 18 centimeter. Now let us see magnification. Magnification is equal to, you know, there are two formula, h2 by h1, or we can say height of image by height of object, or it is also equal to minus v by u. So we better go for this because we have these values known. So magnification will be equal to minus v by u. So we get 2. So the magnification is 2. Now since magnification is 2 and the object height is 3 centimeter, so what will be the image height? Image height will be equal to 2 times of the object, that is 6 centimeter. Okay, so very clear, very simple question.
If you like the video, kindly like, share and subscribe. Thank you.